In this problem, we're asked to calculate the work function of gold. So when frequency hits the frequency 2.11 times 10 to the 15th inverse seconds, or hertz, hits the surface of gold, what happens is that you excite the electrons of the gold. So in this problem, we're asked to find the work function of gold. So if you strike energy, some sort of quanta of energy, HV, on the surface of the gold metal, what happens is that you can get excitation, and then following excitation there's relaxation and subsequent emission. The difference in this problem is that you're hitting it with a quanta of energy sufficient enough to actually eject an electron out of the gold atom. So when you hit it with a quanta of energy large enough to kick out an electron from the surface of the gold metal, you're going to get what's called a work function. Now the work function here is a combination of two things. The work function here is the quanta of energy, and that quanta of energy must overcome the work function and the kinetic energy of the ejected electron. So here this E of K stands for kinetic energy, which is just basically 1/2 mv squared. We do not need that equation to solve for this. Basically what we're doing here is solving for the work function, and that is phi. Okay, that's the Greek letter phi. So utilizing this equation, here's our quanta. It must overcome the threshold energy, or the work function, minimum energy required to kick out that electron. We're not exciting it so that it could emit after relaxation. We're exciting it so that it really just emits an electron. So after it emits the electron, that electron will acquire some kinetic energy. So the work function here, phi, that Greek letter, is what we have to solve for. So we have HV, our quanta, minus the kinetic energy is going to equal to the work function phi. Well, they give us all of that data here in this problem. The kinetic energy here is kinetic energy of the ejected electron is 5.83 times 10 to the minus 19 joules. The frequency of the quanta that you're going to hit it with is 2.11 times 10 to the 15 hertz. And then Planck's constant is a constant that will be given to us. So solving here, Planck's constant is 6.63 times 10 to the minus 34. The units of Planck's constant are joules times seconds. The frequency V is given to us in the problem in hertz. It is 2.11 times 10 to the 15 hertz. Okay, minus your kinetic energy. Your kinetic energy here is 5.83 times 10 to the minus 19 joules. The kinetic energy of the emitted electron. What's happening here, again to reiterate, the quanta on our gold surface is kicking out an electron. It will acquire kinetic energy, EK, and our quanta. Okay, this minus that is going to equal to the work function, which is the minimum amount of energy to remove an electron from the surface of this metal, gold, element abbreviation AU. So doing this on our calculator, taking the product of this, subtracting it from the kinetic energy, we're getting our work function to be 8.16 times 10 to the minus 19 joules. Okay, so this is the energy that we need to sort of put in, plus our kinetic energy. All of that goes into our quanta so that we can kick out, so that we can eject an electron out of the surface of the metal.